Hello guys, welcome back to the channel. Today we are going to solve this problem related to chapter gamma functions. The question says the equation of motion of a particle moving from rest towards a center of attraction point situated at distance a centimeter apart from it is given by this second order differential equation. Here k is the constant. We need to find out, let's say, if the time to reach the center of attraction point is given by this expression t equals to a into root under pi by 2k. So the question simply says we need to use the gamma function somewhere to solve the problem. Let's begin. At first, let's write whatever is given here. Given equation of motion is d square x by dt square plus k by x equals to 0. I hope you can see that this is the term of acceleration. Now let's rearrange it. D square x by dt square equals to minus k by x. Now let's multiply both sides by 2 dx by dt, and we'll get 2d square x by dt dx by dt equals to minus 2k by x dx by dt. Now this can be written as 2d d square x by dt dx by dt dt equals to minus 2k by x dx. Integrating both sides, so after integration this will be dx by dt square equals to minus 2k, so just a constant 1 by x dx integration will be log of x plus, let's write something else, let's say a, where a is an integration constant. Using initial condition, that is when we have x equals to a, right, the initial position of the particle, then at that instant there won't be any velocity because a is a constant. So using this condition in above expression to get the value of integration constant, that implies from here, from this equation, dx by dt square, that is 0, equals to minus 2k log a plus a. That implies a has the value of 2k log a, right? We got the integration constant also. Therefore, now we know dx by dt square is equals to minus 2k log x plus 2k log a, which is, this is like 2k log a minus log b, So this is log a by x, right? After this, we can see that dx by dt equals to root under 2k log a by x, right? Now again, let's rearrange here since we need to find out the total time, right? Or the time required. So this will be like dx by root under 2k log a by x equals to dt, or mm, total time if is capital T, right? Then total time we calculated in this way, integrating both sides. Then x has the limit 0 to a, small a, right? So 0 to a dx by root under 2k log a by x. Suppose the total time is t, right? So t equals to, now we need to manipulate or evaluate this integral here, this part. And as per the question suggestions, somehow there might be the use of gamma functions. So integration 0 to a 1 by root 2k, and now we have log a by x minus 1 by 2, right? And then dx. So here is the inverse function, and we can, I think, somehow replace it with some other variables. Let's see. Let mm, log a by x equals to, let's go with the some other variable z, right? or or x equals to a by e power z equals to a times e power minus z. Therefore, differentiating both sides, dx equals to a minus 1 e to the power minus z dz. That is, dx equals to minus a e to the power minus z dz. Also, let's check the limits here. When x tends to 0, z tends to, x becomes 0, log infinity, z will be infinity. And x tends to a means z tends to log 1, log 1 is 0. So these are the limits. Now let's go back to the integral, this integral here. T equals to, so t equals to, we have 1 by root under 2k integration. Now the limits are changed, integration limits are Uh, at first, let's write all of the things. Log a by x power minus 1 by 2. That is z power minus 1 by 2. Z power minus 1 by 2. And then in place of dx, we need to write minus a e to the power minus z dz. And the limits of z now are when x tends to 0, z is infinity, and here 0. Right? Now we can interchange the limits by using this minus sign. 1 by root 2k. Integration limits gets changed to 0 to infinity, and this minus sign vanishes. Also, we can put this constant a at front, right? Let's place it here, a by root 2k, and we are left with z power minus 1 by 2 e to the power minus z dz, right? Now let's rearrange this integration. The powers of z, 0 to infinity, z power 1 by 2 minus 1 e to the power minus z dz. Now we can see that this is a gamma function with n equals to 1 by 2. So a by root under 2k is a gamma function 1 by 2, and we also know gamma function has value root pi if n equals to 1 by 2. So a by root 2k into root pi, and finally the time required will be seen as a times root under pi by 2k. Hence proved. This is the solution of this problem. If you are confused here, remember the definition of gamma function. Gamma n equals to integration 0 to infinity e power minus x power n minus 1 dx. Okay. We use this definition here in this step, and we got gamma 1 by 2, and again gamma 1 by 2 is root pi. I hope you understand the solution of this problem. If you have any confusion, please comment below.